Yeah, the subsea engineering, I guess, has evolved largely from land. Nobody really, going back 30 years, was designated a subsea engineer. Most of the people who are in subsea engineering got there somewhat by accident. They were working onshore, and suddenly they think, oh, we need to go offshore, and they used shore-type equipment, and they'd started marinising. And as things have got deeper, the technology's moved on. Now, we're still relatively simplistic in what actually happens on the seafloor. We're really little more than complicated piping. But that is in a phase of changing. There are demands to move more and more of the processing from ship and from shore to put it on the seabed, and that creates a huge amount of demand for the future to actually put processing plant that today you can access with a spanner. You know, guys an LNG facility, they'll close down maybe for a few weeks a year, and they'll do a complete overfit of what they're doing. You can do that on land. You can do that on a floating LNG platform. But there is an expectation that a large chunk of that processing will migrate from the surface to the seafloor, and that poses a lot of challenges as far as developing new techniques, new robotics, new methods of being able to change our equipment so that you can keep equipment operating there for the long periods of time. Bear in mind a project like Gorgon, which is one of the biggest projects that's going on at the moment in Western Australia, that's got a suggested life of between 50 and 60 years. So you've got to have reliable equipment that's not very accessible, that's going to operate continuously for a period of 50 or 60 years. It's a challenge. It's a huge challenge. We were at a meeting, this was at the last OTC, at the end of the OTC, where we had a presentation from Cameron, who are one of the big suppliers of subsea equipment. And his, a bit of a one-liner was that subsea engineering isn't rocket science, it's more difficult, which we thought sort of posed it quite correctly, because it is. I mean, the environment you're talking about with at 5 kilometres, the hydrostatic pressure is enormous. The pressure of the vessels you've got to survive with down there are enormous. A lot of the well temperatures, well pressures that you get from these subsea wells are extremely challenging. 15,000 psi is about the standard top design now for subsea trees, but they're going to go to 20 and 25,000 psi trees. We're talking serious engineering here. It's going to be a lot of challenges. I think it's a good field for young engineers who are looking for a challenge and something that's going to dynamically change through their career to get involved in. So I wish I was 30 years younger.
What are the tuition fees for the